Section 5.5, the remainder and factor theorems. So the remainder theorem states that if a polynomial f of x is divided by the binomial x minus k, then the remainder r is the same as the result that we would get if we did f of k. And so let's show what this means. So first of all, synthetic division is the same as synthetic substitution, the same process. And so if we're going to divide by x plus 3, you need to realize that we're actually dividing by x equals negative 3. So negative 3 is going to go in that box. We need to put our coefficients across the top, 2, 9, 14, and 5, noting that we don't have any missing terms, so we don't need any placeholders. And now we're going to do the same process. We're going to bring the 2 down. We're going to multiply negative 3 times 2 and get negative 6. Adding, we're going to get 3. And then we're going to repeat this process. So negative 3 times 3 is negative 9. Adding, we get 5. When we multiply, negative 15. And then we're going to get negative 10. So now, one thing that we're going to do when we dealt with synthetic substitution, we were concerned with just that negative 10. But what you need to realize is that now what we have is the result of dividing that polynomial by a binomial. And so since we started with an x to the third, we're going to end up with a 2x squared. And these numbers that we're left with as a result of our synthetic division are the coefficients of what we call our depressed polynomial. So 2x squared, because it's one less exponent, plus 3x, plus 5, plus we have that remainder. So if you remember when you're dividing with just regular integers, you would write the remainder over the divisor, so it's going to be plus negative 10 over our divisor of x plus 3. And so this is the result that we get when we divide that trinomial by that cubic function by that binomial. And so just to show you what the remainder theorem states, if we were to take that negative 3 and find out what f of negative 3 is, substituting negative 3 in for x, and doing the order of operations and simplifying this, we would get negative 10, which is what that remainder was, what we would have gotten in our previous section when we used synthetic substitution. Now, one other thing I want to go over, I didn't necessarily go over this in class, but something that would be handy to know, because if you're dividing by a binomial, then you can use synthetic division, but you might have to know how to do long division of polynomials. So I'm going to demonstrate this with long division of this binomial. So we're going to set this up the same way we would as long division of integers. So x plus 3 is our divisor, and my cubic is my dividend. And so when I'm going to ask how many times, or x times what, would give me 2x to the third. And so x times 2x squared, and then I'm going to multiply that 2x squared by both those terms. So 2x squared times x gives me 2x cubed. 2x squared times 3 gives me 6x squared. And then similarly to long division of integers, we're going to subtract. And so my first term cancels. It becomes 0. 9x squared minus 6x squared is 3x squared. I need to bring down the rest of my polynomial. And I go through the same process again. X times what would give me 3x squared? And that would be a plus 3x. Again, multiplying 3x times the x plus 3, I get 3x squared plus 9x. And again, subtracting, my first term cancels, becomes 0. 14x minus 9x is 5x, and again, bringing down that 5. Then let's go through that process again. X times what would give me 5x? And that would be plus 5. Again, multiplying, I get 5x plus 15. Subtracting, and I get negative 10. So once again, I'm going to write that as my remainder, plus negative 10 over x plus 3. Okay, so moving along, the factor theorem states that a polynomial f of x has a factor of x minus k if and only if f of k equals 0. In other words, there's no remainder. And so if you're given a problem, again this polynomial, and told that x minus 3 is a factor, that means when you do your synthetic division, you should get 0 in that final spot. And so again, we're going to set that x minus 3 equal to 0. We get x equals a positive 3, so we're going to divide in positive 3. And again, my coefficients. And now doing that same process, bring the 2 down, and multiplying, and doing my addition. And I end up with 0, which means x minus 3 is indeed a factor. Now we need to write this as a depressed polynomial because we're asked to factor it completely. And so now I have, since I started with an x cubed, I have a 2x squared, and then minus 5x minus 12. And now I need to factor this quadratic. So again, I'm going to ask myself, if you recall from the last chapter, what multiplies together to give me a times c, so 2 times negative 12 is negative 24, that adds together to give my b term, which is negative 5, and hopefully you recognize that that would be negative 8 and 3. So now I'm going to break apart and rewrite my trinomial in 4 terms, so that I can ask what can I factor out of the first 2 terms, and then what can I factor out of the second 2 terms, and so then I get that this quadratic factors as 2x plus 3 and x minus 4. Now it asks me to factor this polynomial completely, so please don't forget that x minus 3 was originally a given factor. So when it asks you to factor completely, don't forget to include that original factor. Another way a problem might be worded is if you might be told that given that 4 is one of the zeros or solutions or x-intercepts, remember they all mean the same thing, of that polynomial, find the other zeros. So again, you'll need to get this down so you can factor it, because you can't use the quadratic formula on this. And so if 4 is one of the zeros, I'm going to be dividing by 4. And then you need to make sure that you put those coefficients across. And so then doing the same process of my synthetic division. If you're told that 4 is one of the zeros, you should get 0 in that very last spot. Again, my depressed polynomial, since I started off with x to the third, my depressed polynomial is going to be 1x squared plus 5x plus 4. Hopefully you recognize that you need to set this equal to 0 and factor this. This will factor as x plus 4 and x plus 1. Setting both of those factors equal to 0, I get x equals negative 4 and x equals negative 1. If it asked you to list all of the zeros, you would need to make sure that you list that original x equals 4 as one of the zeros. So this trinomial has 3 zeros, 4, negative 4, and negative 1. So that wraps up section 5.5, pretty short section. If you have any questions, please make sure you ask me.